Hello everyone, welcome to section 3.8, Endpoint Problems and Eigenvalues. So we begin with the question, why do we need eigenvalues? So by now, I would say we have seen a fair bit of this y double prime plus px y prime plus qx y is equal to 0 equation. And we've been fairly exposed to having initial value problems that have ya equal and y prime of a equal to some value, usually 0, but not always. So from this, we question what happens if our initial values are some points ya and yb that are equal to the same value, but a is not equal to b, which will be introduced in this section. For now, we will only be dealing with initial conditions that when plugged into y are equal to 0. So this would be the form y double prime plus p of x y prime plus q of x y is equal to 0 with initial conditions y of a is equal to 0 and y of b is equal to 0. These types of problems are known as endpoint or boundary value problems. So now I'm going to go over some examples of some issues that can happen in an endpoint problem. We'll start with example 1. So first we're going to define y of x, which is going to be equal to a cosine x square root of 15 plus b sine x times the square root of 15. Then we're going to plug in one of our initial conditions, y of 0 is equal to a cosine 0 times the square root of 15 plus b sine 0 times the square root of 15 is all equal to 0. Now, if we just let this all simplify down, we get that a is equal to 0. Now, let's go to our other initial condition, y of pi, a cosine pi times the square root of 15 plus b sine pi times the square root of 15, and we're not going to set it equal to 0 yet. So, from the previous step, we know that a is equal to 0. Therefore, the a cosine term will just drop out since it too will also be equal to 0. Now, this b term will be approximately equal to 0.2108b, and this all equal to 0. Now, we can see that b is just going to be equal to 0. However, this results in what we know as y of x identically equal to 0, thus being a trivial solution. And this is one of our problems. So we're going to move on to example 2 from here, where we will now go over another issue. So again, we're just going to go through the same steps. Y of x is equal to a cosine 4x plus b sine 4x. Going with our initial conditions, y of 0 is equal to a cosine 4 times 0 plus b sine 4 times 0 is all equal to 0. Again, everything's just going to simplify down nicely down into a is equal to 0. Now let's do our second initial value and get the a cosine 4 pi plus b sine 4 pi is equal to 0. And we know this a cosine term will also be equal to 0 because a was equal to 0 as given in the previous step. Now let's take a look at our b sine term. We know that sine of 4 pi will always equal 0 no matter what the value of b. Therefore, b can be anything. It can be real, it can be imaginary. Therefore, this results in infinitely many different non-trivial solutions. And this is another issue that we can run into when dealing with endpoint problems. So, to wrap things up, I hope you guys can see from these two examples the major issues we face with endpoint problems. That is, we can easily get a trivial solution where y of x is identically equal to 0, or infinitely many different non-trivial solutions. From here, I'll pass you along to Akash.